Good morning, everyone. I think it's time to get started. My name is Felienne Hermans. I'm a full professor of computer science education at Free University in Amsterdam. And I'm here today to talk about a programming language for children that I made called the Hedy programming language. And just to give you like the highlight in one slide, Hedy is gradual, Hedy is multilingual, and Hedy is built for teaching. And you might not know what any of those things mean yet, but this is the thing we will cover in the talk. So you just have an idea of the three things that make Hedy unique. If people ask you after the talk, like, oh, what is Hedy all about? If you don't remember anything because you're like jet lagged like me, you can just say Hedy is gradual and multilingual and built for teaching, and then it's like you actually paid attention. So before we go into details, I want to give you like the backstory of how I developed Hedy. Because Hedy, like I think any programming language ever, was built to scratch my own itch. But it wasn't a language I needed myself, it was a language I needed for teaching. Because about 10 years ago, I became a teacher, initially in a Saturday programming club outside of school, but later I actually became, and still am, a teacher in high school, and in my country, high school is between 12 and 18. So every week, I'm teaching kids, right? So the children I initially started with were a bit younger, middle schoolers between 10 and 14, and they needed a programming teacher. So I was like, yeah, sure, children, I will teach you programming. But sometimes people, because I'm a professor of education, people think I have actual knowledge about education. Well, I do now have some knowledge about education, but when I started teaching, I didn't have any experience or knowledge because my background actually is in programming. I have a PhD in software engineering. But the annoying thing about people with a PhD, are there any people with a PhD in the audience? At least a few. Yeah, so the annoying thing about us people is because we have a PhD, we think we know everything. So I thought, okay, how hard can it be to teach children? They're like literally small children. This will be easy. It was not easy. So what happened when I started to teach is that subconsciously I remembered how I learned programming when I was a kid. So this is me behind my dad's very, very big computer, learning to program. But when I was learning to program, there wasn't a programming lesson. There wasn't a programming teacher because I didn't know any adults that knew programming. So how did I learn programming? Well, from a book. I had this book, Basic Computer Games, and it was allegedly going to show me how to make games. But this was not a book that said, oh, this is a for loop, and this is a variable, and this is a while statement. If you would open the book, it would have printed out basic listings. So this is how I learned programming, right? I manually copied all of these things into the computer, and maybe you hear that English is not my first language, so I had no clue what for or if meant, or domain words like velocity. Fun fact, I didn't know how to properly pronounce array until I was in the university. I used to say array because I got it from a book, and well, English is weird. So I had no clue what any of this meant, but also I had no internet or Netflix, so what was I gonna do? As a 10-year-old, I copied it into the computer because I wanted to have a game. And I think many of us, my age, like children of the 80s, learn programming this way, and therefore we think that compilers are great teachers. Right? We've been Stockholm syndromed into thinking that the compiler is our friend. It's like if you're a child and you don't have any toys, right? You have a plastic bag and you draw eyes on it. It's like, this is my stuffed animal. This is how we feel about the compiler. It is my friend. It is. So this is how we feel, right? That the compiler is our friend. This is definitely what I was thinking when I started to teach children. Not explicitly, but it was definitely the vibe I was thinking about. I just give them example programs, they type them into the computer, and the compiler will tell them when stuff goes wrong. So just to give you a little bit more context on the programming club. Initially, we started with a programming language called Scratch. This is Scratch. It is a visual block-based language. So you can click blocks together and stuff happens. And it's sort of magic. This small program makes the cat turn around and make meow sounds. So it's very easy to get started and to get some confidence as a kid. Oh, programming. Oh, I can master the computer. This is good. But then as the children aged a little bit, so they became 11, 12-year-olds, they said, teacher, we don't want a toy language anymore. We want to do a textual language because we see that textual languages are what the real deal is. That's the thing that makes people money. And specifically the school I work in is like an inner city school. So many kids want to go into computing because they know it's a good job. And then this, it doesn't look like a job, right? This doesn't look like a career. So the kid said, teacher, we want to do textual languages. I said, no problem, children. We do Python. Python is a super friendly and easy to learn language, and we can totally smoothly transfer from this friendly UI into Python. Because kids wanted to go to Python. So this is Python. This is what we do, children. We type print, and then an opening bracket, and then quotes, and then some text, and then another quote, and then a closing bracket. And you do that, and you know what then? Then text on the screen. So the kids are like, okay, that sounds like a lot of work for text on the screen, right? But when I was 10, text on the screen was like cool. Like, oh, we can make Zork. Wow, this is cool. So the kids were not so super impressed, but also it was really, really hard. Because if they did tiny things, then already the compiler would like yell at you. For example, if you put an uppercase in P in the print statement, it doesn't work, right? Because then you get name error, name print is not defined. And this creates an interesting cognitive problem because the kid thinks the computer is smart. It can do 314 times 7 in 1 second, so how can it not fix this? And this isn't even super terrible. Like, this error message is doable, even for the children I was teaching, Dutch children. This is understandable, because in my language, this would be name print is niet gedefinieerd. So it's still kind of similar. So they understood what was happening. But here's another one. So here's a missing closing bracket at the end, right? So you could understand that the child would think, the computer can fix this. It's pretty clear what's meant here. But then the computer says, syntax error, unexpected EOF while parsing. So this kid is like, teacher, what is parsing? I'm like, don't worry, child. I have the dragon book right here. Like, I don't want to talk about parsing. Like, I want to talk about parsing, but not to a 10-year-old in their first programming lesson, right? But then all these concepts sort of jump into your classroom. Here's another one. Teacher, I did it perfectly. I checked it 5 times. It's exactly what it says on your sheet. Except it isn't. There's a space there. This is like literally an invisible mistake. Is Python like robust? No, Python is like indentation error, unexpected indent. Teacher, what is an indent? Like, I don't want to talk about that now, but so. Python was not great, and then I figured maybe, just maybe, compilers are not great teachers, right? They're not meant to give feedback necessarily to novices. They're designed to give feedback to professional adults. They aren't a way of learning unless, like me when I was 10, you really, really want to and you have 0 other interests, right? So it's possible, but it's just not very efficient. And the interesting thing is that the conversations I was having with the children in my classroom, like, they were having a different conversation than I was having, right? So when I showed them something like this, I wanted to show them repetition. Look, in programming, there's this idea that you can have one line and you repeat it multiple times and then you can do magic. But then the children weren't focused on the concept. Many of them were just thinking, oh, I need to put the colon there, I need to put the brackets there, I need to put the spaces there. And their brain got so full that they couldn't really focus on the concept. And this idea is called cognitive load. So the syntax creates so much cognitive load in the brain of the students that they can't fully focus on the concepts. So I was intrigued, and then I thought, how do other fields deal with this, right? We as a society were able to teach children language and math. How do they do that without frying the brains of the children? For example, in language, we take it really step by step. If you have a 5-year-old and they're learning to write and they write something like this, we will not say, syntax error, unexpected floating A. We will just say, well done, buddy. Like, here's a sticker. I'm so proud of you for doing letters, right? We don't care. It's wrong. And then later we say, okay, well, you can do letters. You can group them in little groups, and then they're words, and then you can make tiny sentences. And then we add a rule that every sentence starts with an uppercase letter. And then we add a rule that every sentence ends in a period. And without really realizing it, what we're doing here is we're adding expressive power to the language. Because once you can end the sentence in the middle of a line, you can make lines that span multiple sentences. Right? It's like a sentence and a line initially is the same thing, and now it's 2 concepts. So rules gradually change. That's the idea of learning. And this is also true in math. So in math, we also don't teach everything at once. We have mental models that slowly change. For example, if you first learn subtraction, then in many cultures, we have a different word for it. You might say something like 5 take away 3. And the mental model is there are 5 cookies, and if I take away 3, then there are 2 cookies. If there are 3 cookies and I want to take away 5 cookies, I have 3 cookies, right? So there's 0 cookies left. I cannot take more. Only later we tell students that there's something like below 0. I can have 2 cookies that to you. And the same is also true for division. 8 divided by 3, initially the right answer is 2, remainder 2. And then later the right answer is 2 2/3. And later the right answer is 2, 6, 6, 6, 6, 6, 6. So we have mental models that gradually change. And this is fine, right? Children don't forever become confused because they learn something that is not entirely correct, and that's later refined. So then I thought, whoa, these are great ideas. Could we do something like that? Could we teach a programming language gradually? And that, of course, is the thing that Hedy became. So Hedy is a gradual language, and let me show you what that looks like. So this is Hedy, and this is Hedy in level 1. Because it's gradual, it has multiple levels. In level 1, you can simply do print and then hello strange loop. I will show you that it's an actual live demo by adding 1 exclamation mark. And then it just runs. So you don't need any brackets, you don't need any quotes. It just immediately shows you what printing is, so you can fully focus on the concept. From the beginning, we don't just have print, because we also want to make it somewhat engaging. So something else that you can do in level 1 is you can ask something. You can say, ask, what is your name? And then you can echo the answer back. So you do hello, and then the answer will be repeated. So you do, what is your name? My name is Felienne, and it says, hello, Felienne. So there is state, right? I immediately show, hey, children, you can do something like interaction in a computer program, but you don't have to think about it. And just, if you want to do this in Python, it would be something like this, right? So you have to define a variable, and then you have to do input, like this, oops, input. And this is all the work you have to do to convey the same concept if you want to do this in Python, which is like a lot of work. So if you would show something like this to a kid, then it's very likely that they're not focused on the idea of input and output. They're just like matching the brackets and the quotes until the computer stops shouting. So with this simple form, we can say, hey, programming, it's about input and output. And I told you that kids weren't really so very impressed by text on the screen, so we add a few features to make it just more fun. So one of the things you can do is you can have code read aloud to you. So if I do hello strange loop again, and I enable this read aloud, then
hello strange loop.
And this is like super simple. This is just the Google Speech API, so it isn't very hard to do. But kids dig this, especially later on if you have repetition, then you can do like, then it can sing Baby Shark or Old MacDonald. Kids love that. So we really want to show like programming is fun. Like even if you go into a textual programming language coming from something like Scratch, you can make things that are pretty engaging. What I also want to show to you is that our error messages are not terrible. I'm really proud of that. So imagine you make a tiny mistake and you run the code, then it says, print is not a level 1 command, did you mean print? But because our language is so small at this level, it's relatively easy to guess what's going on. So we have error messages that are quite actionable and readable as a sentence. In level 1, in addition to the text-based output, initially we only had text, but that was still very limited. So we now also have the turtle, so you can run the turtle also in level 1, and you can make little drawings. And something that we added recently that I'm super excited about is maybe you noticed that this save button here appeared. You can save this button, and then it creates a file that you can load onto devices like an embroidery machine or a pen plotter. So we're doing this with children in the classroom, that we allow them to make a turtle thingy, and then they embroider it onto their t-shirt. And that also, again, makes it like more tangible and fun and exciting. So as I said, Hedy has different levels. So this was all level 1. And then in level 2, we add variables. But we do it, again, in a very low-key way. So I can say name is Hedy, and then print hello name, and this just runs. This is magic, right? To your programmer's brain, you're like, pfft. But wait, one is a string, and the other one is a variable name. Like, but that doesn't matter at this level. We just want to show children, hey, a variable, you can save something, give it a name, and you can use the name later. And of course, this does create some problems, because if you want to do something like, my name is name, this doesn't work. Well, I mean, it does run, but it replaces name everywhere. So now this is a good way to talk about quotation marks to children. It's like, look, this happens if you don't have them. So wouldn't it be nice if you could tell the computer, like, what is a string and what is a variable name? And then that's a problem that we solve later on. So in level 4, when we add quotation marks, we show this as the problem. And then the quotes are an answer to a problem rather than something you just have to do because the teacher tells you to, right? In level 3, just to take you through a few more levels, we have 18 levels, so I can do all of them. In level 3, we add lists. So we add lists, so you can do a list of animals, and then you can select from the lists at random. So again, immediately we create some idea of this is why you would make a list, because then you can select something randomly, rather than something like define a list and then print list element 1. Like, why am I doing a list if I'm not using the list? And then, as I said, in level 4, we add the quotation marks, but that's the only thing we add. So children can really, really focus on doing the quotes and then not be so cognitively overloaded by all the other things we're learning. So that's just to give you an idea of the progression of the levels. And then level 18 is a functionally correct subset of Python. So we really slowly moved them to Python, and they were like, take away the curtains. I was like, ta-da, now you're doing Python. And it wasn't so super painful, we hope. So that was the gradual nature. So I promised you the 3 unique features. This is the gradual nature. Slowly over time, we're adding syntax and we're adding concepts. But Hedy is also multilingual. And for that, again, we need to do a little bit of a backstory. So when I designed Hedy in the end of 2019, I designed it just because it would be a fun Christmas break programming project, and because I thought it would really add value in my own classroom. But of course, after a while, this turned into proper research. And I did a study because I really wanted to figure out, like, do kids like Hedy? Is this a thing that works? So we did a user study with 39 children in 12 online lessons because it was the pandemic, so we couldn't do actual classroom observations. And we asked these children, what do you see as the benefits? What do you see as the challenges? And what do you see as the improvements of Hedy? So this is very much participatory research. Right? We really want to do this together with students and take their input into account. So some kids really said, oh, those levels, I like it because it's really a step-by-step guide. It really tells me what I should do when. And I was like, yes, that's what we're going for. What I also very much liked is the teacher of this class said that with Hedy, all kids learn some programming. They used to do Python before, and he says, with Python, some kids learn something, but many kids don't learn anything because they keep hitting the syntax wall, and they just never get past it. And he says, with Hedy, everyone learns something. Some kids get to level 7, others get all the way to Python, but at least everyone is learning. So it's like, yes. Another teacher involved in this study, this was a female teacher that was giving courses to only girls, and she said, did you make Hedy for girls? And I was like, not specifically. But she said it's so good for girls because the little steps really give confidence. Sadly, we know that girls often come into programming classes with lower confidence in their programming abilities because, well, society tells them that they will not be good at it, right? So if you're already unsure about your abilities and your first error is unexpected syntax, AOL, then that's going to reflect way harder on your self-confidence if it's already low. So we didn't build it specifically for that, but I do see how that would work. So we also asked children, how can we make Hedy better? And one of the things that children said is, yeah, we would like some better error messages. So I was like, well, our error messages already are quite good. For example, this one, here a child is typing a comma in a place where it isn't allowed. And then this clearly says there is a mistake on line 1, position 12. Why isn't this clear to you, child? Can you read this error message to you? So the child's like, sure, teacher, I will read the error message. A mistake on line 1 in position 12. You typed, but that is not allowed. I don't know where typing is not allowed. I'm typing all the time. They didn't see the comma. And it's like, it makes so much sense if you think about it, right? Because what do we teach children? A comma is a little pause. If you see a comma, do not skip ahead. Stop, right? So the child is exactly doing what we told them, and then now it doesn't work. So we changed this actually, because this should be a comma, and this is a newer version of the UI. We now also have syntax highlighting, as you can see. And now it just said, you typed a comma, but that is not allowed, which makes so much more sense. And these are really like the little things you will only get from observing children being frustrated, that you can really get it to a higher level. But what these children also said is, yeah, we would like to have Dutch keywords. So the UI initially was always localized. So the explanation and the error messages were already in Dutch. But the children said, why can't we program in Dutch? And I was like, really? Like, Dutch children are supposed to be really good at English, and we teach it from like age 6 in schools. Really? But of course, I was reluctant because I was like, that's going to be a lot of work. I don't want to do that. It's like, really? And the children was like, yeah, why not? Why wouldn't we be able to program in Dutch? And I was like, yeah, because it's a lot of work, that's why. Anyway, we did build the localization. So this is the UI as you see it in English. But here we have a language switcher, and we now support 31 different languages. So let me show you what it looks like. Thank you. What it looks like in my language. So this is Dutch. You see that everything has now changed into Dutch, but the commands are still in English. So print and ask and echo. But I have a language switcher here, and I can say, well, I would like to see everything in Dutch. And then print and echo is also in my language, the same. But ask has now been turned into vraag. And if you make an account, which is free, then you can also set your profile language. And you don't get the switcher, and it's just always there in your language. So this is what Dutch looks like. You will get Dutch error messages. Everything is in Dutch. So at this point, I'm like really happy with myself, right? Look, we have Dutch, and then we added French and Spanish and German and Italian. I was super happy. But then I have a friend, and he's from Palestine. And he was like, so impressive. Latin languages from left to right. Wow, well done, Hermans. So cool. So I was like, yes, but it will be a lot of work. But yeah, I have no life, and it was the pandemic, so we did it. We also are available in right-to-left languages, like Arabic. And then as you can see, everything switches. Oh, I have to put the switcher once. Everything changes to Arabic. So everything's right to left. All the commands are Arabic. All the error messages are Arabic. Syntax highlighting works, just to show you if I make a mistake here, then I will get an error message that's also in Arabic. Oh shit, my browser cached the Dutch front-end message. But if you would run it a bunch of times, then that would also be Arabic. So that was, it was a lot of work, but it's really, really so valuable to see children use programming in their own language. And what's interesting is that initially I very much thought this was like a social justice issue, like they deserve programming in their language. And this is also true. But what I also found observing children use this is it's also so very much an ergonomics issue. Because if you have your keyboard set to Arabic, you first have to set it to English to type an English keyword. Then you have to set it again to Arabic to type an Arabic string. And that switching is just so annoying. And it makes also the classroom conversation really hard, because a teacher will say it's print, it's P-R-I-N-T, but children don't know these letters. They don't know where they are on the keyboard. So it's so much also a practical issue, in addition, of course, to also people are deserving of programming in their own language. So yeah, we built that too. So we did Gradual, and we did Multilingual. So there's one more thing I want to talk about, and that is that Hedy is a language that is built to teach with, mainly because I built it for myself in my role of teacher. When we asked children why Hedy works, the children said, well, the levels are a step-by-step guide. But what we also realized is that this also works for teachers so well, right? Because a teacher can just boot Hedy, and then it will tell the children in his or her classroom what to do. So it's really, really clear how to use it. Whereas if you compare that to Scratch, right? If you look at Scratch, I have tried many times to teach Scratch programming to elementary or high school teachers. And you can get them to understand the basics, right? It's not that hard. But then, okay, I understand programming, I understand the basics. Now, what do I do in the classroom? Scratch doesn't have really a built-in lesson plan by design. That's not, because they're not built for teaching. They're built for learning, which really is not the same thing. So then a teacher is like, well, I have to look at all these different lesson plans. There's so many on the internet, but they're all super different. Some might start with a program, some might start with different basic blocks. And you don't know if it's good, you don't know where it goes, you don't know if it's made for your age group. So this is really hard. And then even if you settle on a lesson plan, this again is ergonomics. So you selected a lesson plan, you print it out on a sheet of paper, or you put it in a second tab, but now the child has to move their attention from the lesson to the programming field, right? They have to look at the lesson, they look at the programming field. Oh, what do I have to do again? Look back at the lesson. Oh yeah, this is the blocks I need to use. Look back on the programming interface, and so many energy is lost because it's really hard to understand what you have to do if you don't really understand what's there. So this is also something that adds a lot of cognitive load because you have to keep switching between the UI of the programming and the lesson plan. So what we have built into Hedy, let me show you another demo. What we've built into Hedy is the idea of adventures. So I didn't really show that yet, but if you scroll up in the UI, you have all of these things that you can do in any level. So you can say, oh, in level 1, well, we can do print, and ask and echo. What can we do? Well, for example, we can create a parrot. And this parrot will repeat what your name is twice, right? And we still have to read aloud. So it says,
I'm Hedy the parrot.
I am Hedy the parrot.
I'm Hedy the parrot. What's your name?
Let's do Harry.
Harry.
So it's a parrot, right? So it just gives an idea for children what they can build, and that this is for children, but also for the teacher. You can just say, well, you just do any of these things. You can explore everything that's there. We have like a restaurant where you can order something. Oh, you want to have a red wine? I want to have a red wine. So it repeats that. It gives an idea of, in every level, what is there. So it's really this out-of-the-box solution that tells teachers, this is what's there in level 1, and this is what you can build. There's one more challenge I want to talk to you about, and that's the challenge of managing many different students in your classroom. So I'm currently teaching. I have 28 12-year-olds in my classroom. So just to give you a sense of what that looks like, if this is the lesson plan, there will be maybe one student that's like, yes, I did it, teacher. Look, it's right there. I'm like, yeah, you're my favorite student, right? But then another one is like this, like, yes, I did one, but I need help because I did one thing, and I need like confirmation that I'm on the right track. Like, yeah, sure, I will like explain it to you in a slower pace. And then there's another student, and this is like, as a teacher, my nightmare, because this is me when I was a kid. Teacher, I ignored everything you said, and I built this. Luke, isn't it great? But now I want the palm to be blue instead of green. Can you help me get there? Even if I could, right, there are 27 or more of you. So managing like the level in your classroom is really, really hard. And I think this is really a place where just like the philosophy of Hedy is different from the philosophy of Scratch, right? In Scratch, it is made that everyone can build anything, and then as a teacher, you just have to deal with this, right? And I totally understand that, but we are really trying to make teachers' lives easier, maybe at the detriment of these type of students not being able to immediately reach their potential. So what we allow teachers to do is to entirely customize the UI that Hedy has. So I'm just going to show you what it looks like as a teacher. So this is me as a teacher. So I have created a class. I can go back to the classes so you can see the teacher page. So I see I have different classes. This is my actual class in my actual school, and this is my demo class. So I see there's one user in my demo class called Felienne. This is me in another browser. And what I can do is I can customize the class entirely so that I can set how it looks like for my class. So now you see all the levels are open and all the adventures are open. But I can say, well, I don't want to have any of these levels because it's just going to be overwhelming. I don't want this level, and I just want to have the parrot and the turtle and nothing else. So this is what it looks, this is Felienne logged in, right? This is what it looks for me initially. Everything is there. But now if I save this adventure, I can say this is the customization, and it has now been saved. Now if I go to Felienne in this browser, maybe when the page loads, then it will, yes, you can see that it is now simpler because some of the adventures have been removed. We also have at the end puzzles and quizzes that you can use to show, to see what your students are doing. You can also enable and disable them. So you're entirely empowered as a teacher to organize your classroom in a way that you want to, giving some students access to certain levels and blocking off access to other levels so that the cohort like stays together a little bit so that you don't have to manage your energy between one line of code and 1,000 lines of code, because that's just really hard if you have multiple students in your classroom. So that was Hedy. If you wondered why is Hedy Hedy, it's because it's named after Hedy Lamarr. She was a famous movie actress, but also an inventor. And she invented an algorithm called frequency hopping that's also in your Wi-Fi router, that whenever a level is full, then it hops to a new level, right? See why she is an amazing namesake? So before we go to Q&A, I just want to call out, because I need all of your help. I didn't come here to make friends. I came here to find contributors. So we'd love your help. For example, the 3 things that we're building are also 3 ways in which you can help us. So you can imagine that a gradual and multilingual parser is very hard to build. Parser frameworks were made for exactly 1 language, certainly not for 18 levels times 31 natural languages. So we're really doing some innovative work there. We have a paper coming out in the Journal of Computer Languages about an extension to EBNF that we made that allows us to better define the changing grammars over time. And one of the authors of this paper is actually one of our open source contributors on GitHub. So really, really proud of that, of merging the open source community with the academic community. So this is the paper. It's already online, so if you want to read it, you can find it through our website. If you're not a programmer or you don't feel like contributing to another open source project with code, you can also help us add translations. As I said, we have 31 languages, but not all of them are equally complete. Sometimes people start a language and then after a while they just stop translating, which is, we're still happy with contributions. So you see that some of our languages are more developed than other languages. So if you know any of these languages that are in red, you can help us extend. But if you know any languages that are not yet on our list, we would be super grateful if you would help us with the translation. You don't even need to go on GitHub for that. We have a web UI where you can just translate called WebLate. So you can just translate in the browser and it generates a pull request for you. So finally, you can help us to find teachers, right? Very often if I give a talk like that, people come up to me and they're like, oh, Hedy sounds fantastic. I will totally do it with my children. And I'm like, yeah, your children are not my problem, right? They have at least 1 parent that is a programmer, maybe 2, right? So I'm sure your children will be fine even if you do Python with them or Scratch, or even if you do assembly, because you will be sitting next to them, helping them out, right? So they'll be fine, but who really needs this are children in situations where there's maybe not a computer in the house, where there's not a parent to help them. And if you find 1 teacher, then that's maybe 30 students over 5 years. That's really going to scale, and that's going to reach people that normally don't come in contact with programming. So something you can do is help teachers find Hedy. We have an online lesson plan, and we explain everything with little videos like this is how you do. And we have an online community as well for teachers. So we really, really want to rope in teachers because we believe that this is something that can help them teach. So if you want to join us, you can go to hedy.org/join, and all the information about how to join the Discord and the GitHub are right there. With that, I think it is time for Q&A, but before we start, I follow the 2 holy rules of Q&A. Those are, the first sentence is a question, and rule 2, there is no second sentence. Yes, do we have a mic for questions? Do you just want me to repeat the question? Go ahead.
How long does it typically take students to progress through the series of lessons?
Great question. So we aim for about 2 hours per level. So that means that you have about 18 times 2, so it's almost 40 hours. And that's if you do 1 hour every week in a classroom, that's 1 academic year. So that's more or less what we think it would take you. But of course, this depends on the age and the program knowledge and the expertise of the teachers. But more or less 1 academic year would be enough to go from the basics to Python. And then you can do Python afterwards. Those are not following exactly my rules. So let's start with the first one. Yeah, so the lesson plan. I was already teaching Python before. So most of it was we took what we were already doing in Python and then transforming that into Hedy. But there's very much tension in some of the levels. Like in level 1, I also want to show the turtle because I want to attract children that aren't maybe not so interested in the text. But that means we have 5 commands, which is maybe a bit too much. So it is this, like a little bit of tension between want to make it exciting and want to make it, doable. We have repetition in level 7, and we already have variables in level 2, so level 7. Yes?
If you're starting in a non-English language, by the time you get through level 18, are you in Python in English, or how does that work?
Yeah, that's a great question. So in level 18, you can still do Python in your own natural language. But so then if you want to make the transition, this is going to be a hard transition where it's really hard to do. So like, I am trying to be hopeful that maybe the work we're doing is also impacting other programming communities, and that maybe there will be something like Python in Arabic or other programming language, because it's not so hard, right? It is doable. So hopefully this will create a generation also of students that say, well, now we have to go to Python. Why isn't Python in my language? So that's like, I know this is also a way of making it not my problem, but I do think that's where we could go as a community. But this is really hard, specifically if you have to go to left to right and to a different alphabet. Yeah, that's hard. Yeah. Yes, some of it. So the question is like, does this also work for adults? So we definitely think it works for adults. This step-by-step approach actually works really well. So we're aware of some universities, like our first-year students, are they adults? I don't know, maybe. But so we are aware of some universities that use it, and they just disable all the adventures, like you don't want to do, oh, I'm a parrot, but you can put some other lesson plans in there. And if you want to, you can just remove all our adventures, put your own adventures there. It's not like something we are targeting right now, because I just like children better. It's just more fun, but like the way of teaching will work, and the interface like isn't designed for it perfectly, but you can do it. And we've been hearing from more and more universities, specifically in non-English languages. For example, in Pakistan and Indonesia, we know the universities are using it specifically because of the localization. Yes. So the question is, can I help a school to get started? We definitely have some of the people in our community that are also on Discord have done the same path, right? They're also programmers going to a school, giving lessons there. Of course, it depends really on what type of school and your relationship with the school, how to approach it. But we definitely have had people in our community. I started as someone that wasn't a teacher helping a school. Well, they wrote me in, so that's a risk. But so we have people with that experience that can give you some pointers on how to get started there.
How big is the community? What's it like to be involved?
So we're a pretty active open source project. We close about 150 pull requests every month. That also includes a lot of translation, so it's not just code. We have about 10 to 15 people that are really active, like on Discord, basically every day. But your level of involvement can be really different. So some of the translators, they just come in, they translate for one weekend, and then they add the translation, and then we never see them again. So that's definitely something that you can do. Some people they teach weekly, and they chat about how they taught and what their experiences was on the Discord, like every time they teach. So it really depends. We're also super happy with like drive-by contributors. It's just like, oh, I saw a little bug, okay, I fix it. Yes, that's also fine. But there's definitely also room for people really to join the community to help us also spread this to other people.
Do you know how many schools are currently using Hedy?
Yeah, so a few hundred schools, many of them in the Netherlands, a few also in the US that I know of. So yeah, a few hundred schools, and sometimes also, so you have this interface where you can create a class, but you don't have to make accounts. So sometimes we also see some sort of spike without new accounts, so then maybe just someone is using it in the classroom without creating the accounts. That's also still a way to use it. So we don't always see what classroom usage is versus home usage or other usage, but then a few hundred classes are in the system. So those are definitely schools. Oh, what, you already had a question, so I'm going to do first timers first. Yeah, so the question is like, how do students feel about differences in the constraints? So I think this is a generic thing that isn't just for Hedy, right? If they're doing reading, then it will also be, oh, I've already finished my lessons. Oh, you can do an extra assignment. This is something that's very common already in the classroom. So for a teacher to say, oh, all of you are level 3, oh, but you can already do level 7, this is something, yeah, whether you like it or not, that's not Hedy specific. This is classroom practice because there is such a big difference, especially in elementary school, in the ability and speed and the determination, like how robust children are against errors. Okay, the organization is showing that we should wrap it up. So let's do one more question and then we have to wrap it up. Yes?
You did the survey of the 39 children. You mentioned the benefits and challenges, but you didn't really go into the challenges.
Yes, because I had to cut time. There are videos where I talk about that specific thing. So one of the challenges that children still see is that they have to remember the codes. Even though there's examples, sometimes they forget a certain word, and then there's frustration, like, oh, I forgot this, which still also, I tell them, I've been programming for 30 years. I still forget concepts, but this is something they struggle with. And another thing they specifically struggled with that is Hedy specific is that there are sometimes changes. So then they do level 2 code in level 3. And our parser is sort of robust against that. So if you do code at the wrong level, then we will tell you, hey, this is level 2 code in level 3. But still they're like, oh, why doesn't it work anymore? So that's those switches, which also we know from language and math education, switching your mental model, that is hard. So we can do something with error messages a little bit, but of course also this remains just a problem of learning. If people are interested in joining the community or just showing support, I have some stickers. So if you want to ask me a question, then grab a sticker. Feel free to do so.